So the next topic, it is very, very easy from now onwards till you start Spark. Why it is easy? No worry about too much technology, coding and all. If you learn, you can do it very well. Learn means just if you know the commands and if you know the simple statements and such things, you will be able to do it very well. So the topic that we are going to enter is called NoSQL databases. The first thing is, what is the full form of NoSQL databases? Anybody? What is NoSQL databases mean?
No.
It cannot be accessed by SQL.
There is no structure is not known.
NoSQL means not only SQL, okay, which means SQL also can be used. So the first thing to understand is not only SQL, right? Now comes lot of theory, okay. Why did the people go for NoSQL databases? What is the advantage? What is the disadvantage? What cannot be accomplished? So we will see all that things. First of all, you might have heard my discussion if you have come for that Minio, right? I had mentioned that there are two types of models in the entire data warehouse world which are very prominent. One is called the Kimball model and another is called the Inmon model. Both are attributed to two great scientists, Inmon and Kimball, right? Inmon model talks about databases, normalization, all kinds of primary foreign keys, constraints, etc. Inmon told any database should be modeled. First you will model as a flattened table and then you will think which can be reduced, common items, and then you will make a one-to-many relationship or many-to-many relationship. You will create what you call as ER diagrams, entity relationship diagrams, and then you will use the database. And there is another class of people, the reporting and the business decision makers and the analysts kind of people, right? They will connect to this place. They faced a big problem. What did they face? Assume that I have got a Twitter representation in my data model. So I have got a post table. I have got a ID table, Twitter ID, for example, all your personal information. And the post is having many comment table. Comment may have tags inside it. So see the relationship. One ID can have many posts. One post can have many comments. One comment can have many tags. Tags can be again associated with an ID. It becomes a nice joint structure in relational database models. First of all, the way in which this is represented is called a relational database management system, correct? There are three types of systems: network databases, there is hierarchical databases, and there is relational databases. Network and hierarchical were used in the earlier days, but the one which became most prominent in the industry is relational databases. Why? Because a scientist named E.F. Codd came in around 1960s, 70s that time and told that there are 12 rules. All the 12 rules should be satisfied by any database storage system, and most of the rules are satisfied by relational database management world. Oracle supports about 11 of all the 12 core rules. Similarly, Teradata 10 to 11. So relational database management systems are always constituted using relations. And what is a relation? Relation is what we call as a table. So even though we say that this is a post table, this is a comment table, it is actually implemented as a relation. And we also call as something inside a table as a row, and the actual word that you should use is not a row, it's called a tuple. So what is a relational database management system? Relational database management system is a combination of relations with tuples. We call relation as tables and we call tuple as rows. Then we create all our tables and the keys will be joined by primary foreign key constraints and you are going to give it to the analyst. What is the problem analyst has to face? The issue is they will have to write a very complex SQL statement in order to combine all these data by joining properly. And you will use left inner join, you will use outer joins, you will use internal simple joins, you will use distributed joins, broadcast joins. So many technologies came in. How you access the data. And the people told, no, this is not good. So some of the companies like Business Objects, Cognos, reporting tools emerged. What they told is that, hey, this is a very complex data structure. Don't worry about that. You put Business Object or Cognos as a semantic layer. And leave to me, I mean BO and Cognos, the responsibility of creating a business model from these complex structures and then give that business model to the decision management analyst and the reporting people because these are all mainly the business people. They are not worried about what is the complexity. And that is where your data lineage and your metadata and everything is coming in, which is facilitating the business users to derive the information in a consistent and easily understandable way. So they created a semantic layer. And what is the name of that semantic layer? It is called a cube. That's why all these tools will create something called a cube, which will represent the data in a sliceable and diceable form. What is meant by slicing and dicing? Assume that I am giving you Vasanthi, all the purchases that you made in Patel last year, and then your husband wants to see how many times you bought biscuits, how many times you bought vegetables. You will have to slice and dice the data. That's called a cube. Anybody? A cube is a representation of a technology called OLAP, Online Analytical Processing. From where your relational database management is created, normally this relational database management system is residing as the data warehouse. What is a data warehouse? Data warehouse is the single truth of data in the organization. What is meant by single truth of data? Data warehouse cannot be edited. It can be only consumed. It can be only read. Then what can be edited? That is where your OLTP systems will come in. Online transaction processing systems. So in Citi or in Florida Blue or in Bank of America, whenever the transaction is happening, it is attached or stored into a mainframe system or a huge Oracle system. That is your OLTP system. Concurrent writes, concurrent reads, millisecond response, phase commits. If one is rolled back, the other is also rolled back, etc., etc. That is happening in the OLTP system. from the OLTP system, you will write batches of information transaction into your what? Data warehouse. This is the DWH or EDW, Enterprise Data Warehouse. These batches are normally written using ETL, which is called extract, transform, and load. Nowadays, the people also will tell it as ELT, extract, load, and transform. For big data, it is ELT. For normal, it is ETL. Why it is called ELT in big data? Where is your MapReduce happening? In your Hadoop. So, you are loading the data to Hadoop and then you are doing the transformation. That is ELT. What about ab initio, data stage, Informatica, etc.? ETL. Extract, they will do the transformation and will load the final data into the data warehouse. Right? So, ELT, ETL, etc., are the tools that are being used and the technologies that are being used, and the tools are ab initio, data stage, Informatica, Pentaho, Kettle. All these are the tools that are being used today. And that is where your data lineage and everything is coming in while you are doing the transformation. Can I capture what has been transformed, who has been transformed, how much has been transformed, how many nulls were there, how many records were skipped, etc., etc., etc. All those things will come as data lineage. So, data lineage, extract, transform, ETL, OLTP, and from there it is coming to OLAP. You created your data warehouse. From the data warehouse, you created your cubes, and the cubes can be or called as OLAP. So, what is the difference between OLTP and OLAP? OLTP is for concurrent reads and writes. It is not the single truth of storage. Storage is always your data warehouse. In the modern world, in the future, that storage will become S3 or object storage. Why? It is far better and efficient than storing it in a traditional database in terms of the cost, in terms of the metadata, etc., etc. You have heard me. Right? Now, if you have a data warehouse, you will need to process the data from the data warehouse. That is where again ETL tools will come within the data warehouse in order to transform it. And where the world is going, they are using MapReduce, Hadoop technologies, all these kind of things that we are going to study, and then they are going to use Spark, etc. for converting into the relevant way in which you can access the data. Cubes, as I told you, are OLAP, but normally before that OLAP, they will add a word. R or M or H. ROLAP, MOLAP, or HOLAP. What are they mean? If I have an ROLAP, it is a relational cube, which means that the entire data is residing in the cube itself. Okay? If you are adding the word M and saying that it is a MOLAP, some data will exist here, and when I click on 2015's data, it will point me to the database. So, entire data is not stored in MOLAP. Whereas ROLAP, everything. So, the size of ROLAP will be big, huge. So, which one you want to use? Business decides. Do you want everything together and you want very fast millisecond response? ROLAP. Drill down and all, it is okay. It can come maybe after 5 minutes, after 10 minutes. MOLAP. And some people will use always, if A and B are there, then A plus B is also there, right? ROLAP plus MOLAP together is called a hybrid OLAP or HOLAP.
I mean, in real time, how it is different? How we can know the difference, right?
What?
ROLAP and
Time of access. Drilling down takes time means from the relational database, you are pointing to the other database, then it has to go through the joins and then it will bring the data. So, time by time. and as well as space. You look at the space of a MOLAP cube and a ROLAP cube. Huge difference. This will be 10 gigabyte, this will be 1 gigabyte. Why? MOLAP. Why? Because it will contain only necessary data that is frequently accessed, and the other data it will be linking to the original database.
Sorry, I missed it. What does M stand for?
MOLAP. There is no word. Multidimensional, the people will. MDX is another word that is being used to represent MOLAP. Okay. If you want to know what exactly all these things, and is there any Hadoop related tool, okay, why I'm telling you all these particular tools is you make some notes somewhere. If you are going to interviews and all, they will ask that, oh, what is a MOLAP, what is a ROLAP, because without these fundamentals, learning Hadoop and understanding Hadoop is not accurate, and that is how they judge you, right? It is not that I know MapReduce, I know what is a mapper, and what when you are going to use. So if I am asking you, you understood MapReduce completely, you are attending an interview, and the question comes to you is that, can you tell me an end-to-end scenario where you are going to use your MapReduce program? What's your answer? You have to tell from here, and then you have to tell that I have an OLTP system, and in that OLTP system I have my data, and I am using an ab initio and data stage or kind of ETL in order to transform into my data warehouse. My data warehouse contains Hadoop. Now comes the biggest problem. I have moved away from ETL to ELT. Why I moved? Cost. Because my ab initio was costing me millions of dollars. By loading directly into Hadoop using the available technologies, I made the ab initio footprint very thin, and I have created good cost save to the company. And now the data is here, and it is loaded into Hadoop. Now I want to process that. And the best way to process the data in MapReduce, once the data is already loaded, is MapReduce. That is where my MapReduce is coming in. And now to store it into the results for different departments, I used a partitioner, where retail department got retail data, marketing department got marketing data, etc. And to make the things faster, the processing was very slow, I used a combiner. See, that's how the story should be. And once I got all the data, then I used another tool, and just remember the name of this tool, called Apache Kylin. And that heading itself is telling you what exactly Apache Kylin is doing. And what is that heading is saying? It is telling that it is giving you what? Implementing OLAP in the Hadoop platform. Just now I told you, OLAP is nothing but the cube. So you need a cube out of the Hadoop data. Kylin is an example. So if you click on that, and then you go inside, and if you read, what is this written? MOLAP cube. Now you know what it is. I'll make it bigger. Right? It uses HBase, and it creates the data like this, and it creates a final OLAP cube from you by taking the data from all your Hadoop and all, and then make it available. But it doesn't use Hadoop, it uses HBase, which we will see later.
So you can have any database on HDFS, or is there only certain databases you can have on HDFS?
What is meant by database on HDFS? There is no database in the world on HDFS. HDFS is data. It is not a database. Hadoop FS minus put your data. Your data from the database is copied into Hadoop. Hadoop is not a database.
But you said this is a data warehouse here, right?
Data warehouse contains the data, not database.
Correct. So you can have the data warehouse needs a technology, right? You can
Right.
So you can have SQL. What is the data?
Hadoop, HDFS. HDFS is a file system. It is not a database.
It's like a storage, right?
It is a storage.
Like data drive.
Okay? It is not a database. Don't confuse Hadoop with a database. Hadoop is not a database. Oracle is a database. Understand the difference? You cannot write SQL on Hadoop to get select star from. You have to write MapReduce. Right? So, that is the brief summary of what is happening in the in-mall model.
What is HOLAP?
Pardon?
HOLAP.
Hybrid. Both combined together. Okay. Some data is in MOLAP and some data is in ROLAP. Less used, most widely used is MOLAP, and you will hear MOLAP also as MDX, multidimensional structures, multidimensional extensions. Multidimensional means it is also a kind of MOLAP. And now, what this guy has told, Kimball, what is the problem with all these things? What Kimball told is all the data will be stored as a star model. And what is a star model? Okay, can you convert this post ID comment tags? This is a school exercise. From Inmon model to Kimball model, how it will look like. There will be a center table. Where is my tweet? Okay. This is ID. This is post is, of course, this is comments, and this is tags, this is time, this is location. Please look at this. Ravi's ID, somebody else comment, and somebody else tagged that particular message as belonging to big data at 2018 January from Jacksonville. Whatever I typed is one row. By ID, see the way in which I am telling. By ID, by a tag, by a time, by a location, what is the message? Right? So this is called a fact table. And these are all called dimensions. And when you have facts and dimensions, it is called a star model. There is a little bit different variation also, snowflake model, don't worry about it. So fact and dimensions. Can you tell me what is the advantage? You give it to Cognos and business object, then you will see the fun. Automatically it will identify what is your fact and what are your dimensions. And then you just drag, drop, your report is ready. That is what he is doing, Microsoft SRS and all those things, right? Fact dimensional model. But still, if I ask you to find out all the messages by a particular location, it is very easy. Look at that dimension. By a location, by or from Jacksonville, find out all the tags. Very easy. You can just find it out. So aggregation and everything will become very easy. But still some joins becomes difficult. So some people will prefer to use again an OLAP or cube on the top of star model also, and then we'll create the reports. So it's optional whether you want it or not. It depends upon your business case and the time that you need the result. Still, remember, it is not in memory or it is not stored in a cube, right? So always it is better whether it is a fact dimensional model or normalized model to store it in a cube.
So Oracle BI uses the star model, right?
No,
Business intelligence.
no.
The
You can.
reporting tool that we use.
Oh, it can connect to a normalized model also. Never a reporting tool will tell you that I want to connect to a star model. You can, you may, or you may not. It can connect to a simple table as well.
No, the one we have at FlowW, the BI, where we drag and drop for the reporting. So that uses a star, right?
That is because there is a star model already available. Assume that there is another database, Oracle, and you want to connect and you want to create a report. You can, right?
Yeah.
That's what I mentioned. These tools will allow you the facility. It's upon you to either connect to a star model. Connected to a star model and for a dimensional model or for a fact dimensional model is easy.
We recently developed an ETL on fact and dimension and connecting it to BI.
Okay.
The same thing.
From where the data is coming in?
We created the data. It's coming from Informatica server.
Okay.
So we are creating. We created already the model.
Okay.
Different models, dimensions, time dimension, and different dimensions.
Okay. And then you gave it to
Power BI.
Power BI.
We are
Very,
reporting.
yeah. For the reporting. Oh, your metadata model. Okay. Now you know who accessed what, that kind of thing, right?
When was the rules developed? What are the rules?
Perfect. So that's a perfect application, right? Informatica server has got all the data. She created that star model, and from the star model, a reporting Power BI came in, and in Power BI, you will connect the fact and dimensions will be there by which particular user, which table has been updated by which rules. you can get all that data.
And Kimball is faster because the data is denormalized.
Absolutely. Because here you have to have joins. So this suffered performance. And how you will overcome that performance? By cubes.
So Ravi, in this case, right, when you're using an OLTP, sorry, you're using your ETL tool to move data from your OLTP system into Hadoop. That's in the form of files, right? Just files.
Right. It's always files.
And you can have any kind of file. Like, is it if you want to like? I'm talking strictly about a data warehouse. Right?
Remember PDF we did, right?
I may not be here.
No. So we did PDF. And I told about images. You can do, provided you will write the corresponding record reader and mapper and the input splitter. I gave you that example.
So, but to have a data warehouse in Hadoop, right, you can have the files can be in any format.
Any format. But if you want to process that, now comes the intelligence. That is where the MapReduce programmer comes in. If I have text file, I loaded all the data, plain, simple, no need of any extra technology needed. If I put images, it is JPEG. How can my Hadoop program read JPEG? What I need to do? I need to create my own mappers, my own PDF record readers, sorry, not PDF, record readers, etc., etc. If I have PDF, I have to create my own. They did that. In one of the videos, you can see completely how the PDF is being processed. You used the Apache PDF box, remember? Right? And then we extracted it. So depending upon the data, you need to have the corresponding parsers, which will read it and which will process it. But to your question, any kind of data. That's what Hadoop brings into the table. Lot of unstructured data, right? So the world is very happy with all that particular approach. And whatever I mentioned is till 2008, 2009, 2010. Then started a small issue. The issue is search for Martin Fowler polyglot persistence and press enter. So you will see polyglot persistence, Martin Fowler. Martin Fowler considered to be one of the very, very well-known person in the world of refactoring. He's a chief scientist at ThoughtWorks, a great company. And you click on that PDF, which is coming as the second link, right? Again, if I go back, you will see this NoSQL polyglot persistence with a PDF, right? Just click on that and make sure that this is downloaded when you go back. And the first guy is the Martin Fowler, Martin Fowler. So SQL has ruled for decades. It persists data, it has got application integration, it is standard, it has got concurrency control. What is meant by concurrency control? 1,000 people writing to Oracle, any problem? Nothing. 700 million customers, State Bank of India, using Oracle in the background, not a single problem. Concurrency. Well known, one of the best databases in the world, RDBMS. Still today, we have the best OLTP, one answer, Oracle. Best data warehouse, maybe Teradata. Data warehouse is different from OLTP, that's why I told you. So, and reporting. So, SQL was very, very widely used. Relational database management system, super powered. Everywhere it has been used, wherever you want single version of truth. But what happened is, once the days are gone, the people came up with different technologies. They told that rapid access for reads and writes, hey, Oracle is not better, RDBMS is not better, I will use Redis. Okay, how to take it? This one? No. Yeah. I'll take it Redis as the financial data. RDBMS proved to be the best. Look at all the banks. RDBMS is being used. Shopping cart. Because data is growing, right? Because data is growing and you need more and more applications, Amazon kind of shopping carts you need. React is a database system which is best suited for that purpose. I remember in the school days I was crying for a new shoe and I never got a new shoe until I get some mathematics 50 out of 50. Then only my father will buy a shoe. Okay, there was one single pair of shoes that is being used and you will use it for 2 years, 2.5 years, 3 years. Many of you are familiar with that, right? Now you look at a kid come to my home. That shoe for that stupid Crocs, something came up and then the 1,000 different varieties of Crocs, right? And then 100 another different varieties. Halloween another variety. Huh? Some child that was not. It is too much, right? When you pee 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 pee, that sound will come. Some lights will come. When jumping, the another light will come. Exactly. The database world is also like that. There was one oracle, right, which satisfied the entire organizational needs. They are told that no, this is Halloween, this is what, this one, this one, this one, this one, this one. Different databases came in. Look at that. Catalogs, MongoDB. Okay, I think it is because of white color, it is not visible, but you can just look into that, right? Reporting, RDBMS. Analytics, Cassandra. And then user activity and logs, again Cassandra. So what do you understand from that? It's very clear, right? One database does not suffice the needs of an organization when you have different types of applications. Just take Florida Blue or Citibank kind of companies. Florida Blue, healthcare, different types of documents. I need a storage which is not following a particular table. I need to store a lot of unstructured data. I need to store EMR, electronic medical records, store X-rays. I cannot convert everything into blob, BLOB, and then store it in an Oracle database. So, different systems and different things came in. That is where the new paradigm came in into the world called not only SQL databases. We will be covering 3 NoSQL databases in the course: MongoDB, Hive, and HBase. All these are NoSQL databases. MongoDB is not part of big data. I'm just teaching you for your knowledge purpose only.
It's not part of big data model.
No, it is not. It is not considered. MongoDB is like, or is Oracle part of big data? No, right? Similarly, it is a technology which is already existing independent of big data. But it is often considered as a NoSQL database, and NoSQL is considered to be a technology along merging, gelling with the big data. That is why it is considered as a big database. But actually, if you
But
think
it still can handle big data, large data, right?
large data set, anybody can handle, right? You are understanding what I'm
Oh.
saying, right? Oracle also can handle large data.
Okay.
What I'm saying is it is
Just
not
because
part
it
of
is
the
NoSQL.
core Hadoop ecosystem, right? It is not part of Hadoop, right?
Cassandra is NoSQL.
No, it is not part of Hadoop.
No,
It is a
it's
NoSQL
NoSQL.
database, absolutely. So, NoSQL databases came. Now comes the question: when should I use NoSQL database and when should I should not? So, what is the first rule I told you? One which governs relational database management systems, F code, right? There's a second rule, gap theorem. Okay, Please understand clearly. This is how you should articulate. One who cannot articulate cannot get something good. You should know why always. So what is the need? If Martin Fowler told all these things, but when or why should you use a NoSQL database? How will you take a decision whether I should go for a NoSQL database or not? So listen, that is governed by CAP theorem. And please do search all these things once you go home. And what is CAP theorem saying? Each letter stands for a word. Consistency, availability, and partition tolerance. CAP. That's what CAP theorem is saying. I mean, the full form of CAP. Now, what is this theorem saying? Out of these three, only two can be satisfied at the same time. And please don't ask me why. It's a research. Years of research in the MITs and Stanfords of the world. And finally, the CAP theorem says that out of three properties, consistency, availability, and partition tolerance, only two can be satisfied at the same time. About your storage, whatever storage you take, Oracle to Teradata to anything in the world. They have done a lot of studies and simulations and tests and all, and they came up with this truth. Now, what is our problem? Partition tolerance is always satisfied by all the databases. So this is guaranteed. What is partition tolerance? If any failure happens, I should be able to retrieve the data. Most of the databases, Hadoop, yes. If the one node is failing, can you retrieve the data? Yes. Similarly, Oracle, yes. RAC and all the clusters, disaster recovery and all kind of things, right? Redo logs and everything, all the facilities that are provided in the databases. So, partition tolerance is 100% guaranteed. Now we are in a deep trouble. What is the trouble? Out of consistency and availability, only one can be satisfied at a time because this is given. Good. Consistency and availability. Which one you want? What is consistency and what is availability? Okay, listen. I am having my bank application in my mobile phone. I want to withdraw $100, right? In my account, let us say I have $120. So I withdrew or I transferred $100 in my mobile application. Then I wanted to buy an Amazon book which is costing $50. And I immediately went to Amazon and I am trying to buy a $50 book. Will my bank application or mobile application allow? No. Why? The data is consistent. Why? The database where the data is being represented is getting updated immediately. The word immediate. It cannot even wait for a fraction of a millisecond. The changes that are happening. Now I'm doing another thing. I'm using my mobile application and I transferred $100 and then I logged into the computer and to the same website. And then I wanted to buy an Amazon book for $50. Is that allowed? Not possible. Why? The mobile applications database got updated. Maybe the web applications database may be different, but it is consistent. Consistency is very, very important for OLTP systems. So you can never put a NoSQL database on an OLTP system because consistency and partition tolerance are satisfied by only RDBMS. Now comes the next important point, right? I have my X-rays and I have stored my X-rays into a database. Is it necessary that immediately in the next millisecond that X-ray should be available? No. It is eventually consistent. Maybe tomorrow the database might get updated, correct? Are you getting the clear idea? But it should be available. It must be available for the doctor either today or tomorrow or day after tomorrow. But it should be available. Are you getting that? Availability and partition tolerance. If they are your concerns, then you will go for NoSQL databases.
But even RDBMS has availability, right?
No, it's not 100% available. How many times you will get the message? If suppose I am doing a migration of my database, what will happen? What will you see in the website? What will you get a message if I am logging into a bank telling that by on 30th evening 5 o'clock to 6 o'clock? What is happening?
Also updates or something going on.
Right. Why are you saying it's always available? And another thing, what happens on the Thanksgiving Day evening if you could have logged on to Amazon? What might have happened?
So you're
Too many requests, please wait. I got it. That fellow made 5 billion that day, sir. We are studying big data. What? Simply sitting there, created a platform and minting millions. Right? So, availability, if that is your concern, don't go for consistency because CAP theorem says both cannot be. Somebody came and told that we will support consistency and availability and partition tolerance, but we will not tell it as 100% consistent. We will tell it as eventually consistent. Eventually consistent and 100% consistent difference is instead of millisecond update, I will do 1 second wise update. Are you happy with that? Then you go for Cassandra. That is why Cassandra is so famous. Cassandra has tried to give all the three with eventual consistency. You will always hear this word, eventual consistent. Okay? So understood? What is NoSQL? When to use NoSQL? Right? Availability and partition tolerance. And what is NoSQL databases? It provides you the facility to write not only SQL. Right? Now let us go to the material. So I think I have given you this material. I think on the first class itself I have given you. It is in PASA. PASA. So if you go to the resources, is it having only two? Day 2 is there, day 1 is there. Yeah, I think it is only 2. So I have to get you the third one. I'll give you. Give me 1 minute. We'll pause this. Okay, so I'll go here and what we'll do, we'll go to the Piazza and then just download the third material also. So piazza.com and then piazza.com. And if you look at the resources and you will see course material 3 and just download it. Okay, so here there is a link, you can just click on that and you will get the material, download, and in the downloads you should have it. Okay, right, let us learn little bit the fundamental and then we will go to the details. These are all marketing material telling that okay, what are the different types of databases and all. I'm just straight away going, and this I have already explained to you. Cap theorem is not described in this particular material, so I have just explained to you what is cap theorem also. Okay, so from here you should know. It's exactly the table structure that I have mentioned earlier, right? Where you are having the different databases and you are going to use tags, posts and comments. There are 4 tables. Each are connected. This is the relational way, right? One table is connected with a multiple table. This is how you will be creating the relational database. You will have primary keys, foreign keys and all. For example, what is the primary key in these 4 tables? ID, which is common everywhere. Let's convert this. So see the way and you tell me what is the difference. This is how you will represent it in MongoDB. Again, please look. This is the table that you have in MySQL or your Oracle or anywhere, right? And what are these tables? Tags, posts, comments, etc. You can see a post can have many comments. Every post tag is associated with a post and every post tag is associated with the tags. That is represented, and now comes the representation in MongoDB. So tell me what is the difference?
Everything in one.
Yeah, that is the first thing everybody gets it, right? Everything is combined into one. Next, one post have many comments. How is that combined? Look at this again. One post have many comments, right? So tell me how that is represented inside this.
Nested tables. Tables.
There is no table. Do not use the word table at all now because you are in a different world now. There are no tables.
It is linked to the type.
How? That is a relational database.
Is it tags or something?
Huh?
Is it tags or no?
It is not tags. A post, I have given a post that Amazon conference was good. You gave a comment, thumbs up, liked. Shashi gave a comment telling that, okay, next time we will be there. So 2 comments, 1 post. How will I represent?
It's like column hierarchy.
There is no columns. There is no rows.
What is this called? It's not a table, you said. What is this called?
So we have to define some things, right? This is called a document in MongoDB. No tables, no rows, no columns, nothing. A document. Right? And see the way it is represented. It is mathematical little bit. Now you know the reason. Every document has got an ID. This is automatically created by MongoDB. Okay? It is not created by you. It has got a title, it has got so many things, and it has got a comments. And now you know what is this symbol. This is an array. So, if this is my tweet telling that Amazon conference was good, this will be his comments, and after that I will put a comma after this curly brace, and then I will write Shashi's comments. So, it will contain millions of comments. See the way in which the data is represented. So what you are understanding from this? Everything is in a set of curly braces. The curly braces internally can contain nested elements, like in programming nested structures. And that nested structures can be array or can be just a list of values. For example, the tags, databases, comma, MongoDB, comma, awesome. Look, there is no curly brace here. It is an array of values. Whereas here, this is an array of, again, a structure. Are you clear? You getting the idea? What is this format called? Priyanka? What is this file called? If you write the data like this, what is it called? JSON. These are all called as JSON. And what JSON stands for? Have you never heard about JSON? JavaScript object notation. From where it came? Just a little bit of history. Look at this. Have you ever experienced that in the Google, when I type, let's say, new year, automatically the Google is filling out all the possible things? What is it called? What is it called, Krishna? Ajax. Ajax means asynchronous JavaScripting in XML. Whenever you type it, here you're laughing. You did you do all these things in the school or not? In the computer science. Ajax retrieval of the data. This is a very primary thing, right? It is every website is implementing it. So Ajax needs asynchronous JavaScripting, right? For that, whatever is to be populated is coming back in JSON. Okay.
So this data is called JSON data, or this what is it? What is JSON here?
Representation. Representation is called JSON. Okay. The data is your data. Data doesn't have a. Okay. Tell me what is this? A, B, C, D, Q, R. Is it called a data or is it called a table? That's the question that you ask me now.
This is table.
The table contains data, right?
Right.
This is a JSON document which contains data.
Right.
Clear? Let's have a little bit of fun. Can I take a picture of the class? No?
Well, are we supposed to be working? I'm giving you a good
Yeah,
smile.
please work. Krishna, please work. Are you in Google? Are you in Skype?
Yeah.
You are?
No, I can open it right now.
Okay.
I'm connected to my carrier.
Please open Skype.